Hey everyone, so today we have a master's student from Texas. So yeah, you have a bachelor's in electrical engineering, then you took a master's in computer science.
Yeah.
Nice. Oh yeah, just give a quick background on yourself for the chat.
Oh, okay. Yeah. Basically, I had like 2.5 years of experience. Title was software engineer, but it was doing like React web development, Node, JS backend stuff. But now, like I'm in my bachelor's, I was in like electrical engineering, but I didn't like the hardware part, so I switched to software, computer science for my master's. Finally in master's, and then started in 2022, graduating in 2024, and bam, the market is like one of the worst it's ever been. But yeah, still trying to going for like actually solving LeetCode questions in like a good interview environment rather than just staring at the screen and just like coding silence.
And then for context, Alan has solved over 900 questions.
900.
For how many?
Yeah, but 900, let me see right now, 929 questions, but over half, 500 of them are like easy, 370-ish medium, and only 30 hard.
Nice. Yeah.
Yeah.
Still a good amount. Like
And
you still got a lot of
yeah,
breadth. Like medium
I
questions
did
are oh go ahead.
a LeetCode contest, but so far my ranking is only like 1674, so it's not like super good, just there.
Yeah, that's. I think that's still good. That might even be higher than mine. I did like one or two, and I only solved the first question. But let's see. No, like, yeah, this is good stuff. And you said that you're not really used to all the time you've been doing all these leak codes. You've just been
Not
doing it in silence.
80%, 80, well, recently is trying to talk to myself,
Yeah.
like trying to pretend I'm in an interview, talking to myself, like writing comments, like doing it. But most of the time, especially during like lead code contests, it's just like in silence and then like typing it out and then debugging using print statements, which is not like a good way to dry run things.
Yeah.
So my approach isn't like interview style friendly.
Okay. Let's see. Let's see how you do here. How are you with the different questions like graphs, arrays?
I would say weak, weaker in greedy, advanced graphs, intervals, those kind of questions. I did like 100 some questions in LeetCode 150, and let me see here. Yeah, some of the math questions are okay. Greedy, yeah, and then dynamic programming, the more advanced dynamic programming problems, backtracking. These are my like weaker areas.
I see. Oh, like oh, wait. What is your weaker areas?
Like backtracking, advanced graphs,
Advanced graph.
like more difficult dynamic programming.
I see. Okay. Sounds good. All right, let me think of a question. Okay, we'll do some warm up. We'll do one to two questions. We'll just see. Depending on how you do, we'll move on to more questions.
Hmm. Okay.
So for this first question, wait. So we're gonna be given a root of a binary tree containing digits from 0 to 9 only. From each root to leaf path in the tree, it represents a number. So
Mhm.
I'll show you what that looks like in the drawing. So we're
I
gonna.
think I might have done
Oh,
this
you've done
one
this
like
question?
an hour ago actually.
How
I
was
was
it?
because I was going through your
Yeah, yeah, yeah,
75.
yeah. Okay,
I was going through your 75, so I think I did this an hour ago.
no problem. Let's see.
But that's still okay.
Did you do the min
That
stack
doesn't mean
question?
the mince, which one?
155 in the design questions.
Design. I don't think I really do well in design questions, that's for sure.
Okay, let's see.
Yeah.
Let's try this one because it's more of it's the easier one on here. Oh, they moved it to a medium.
Oh.
Let's see. Give me a sec. Let me think. Let me think.
Yeah, but also like just because I've did it before, that doesn't mean I can perfectly do well in an actual interview
Yeah.
setting. There's a difference.
Can we pause the video? Okay. Have you done this question right here?
Let's see. Generates all combinations of all form phrases.
So, for example, if
This
I
one I don't think I did well of it. Even if I did, I didn't do it myself. Yeah. This is the type of question I don't think I would do well in like an actual setting. But yeah,
you want to
I
try,
think yeah. Let's see if I can think of something and try it, yeah, for sure.
yeah. If you can't, we'll just move on to the next question too. I'll give you like 20 minutes to solve this, and we can move on. We can focus on
Okay.
breadth over depth, just to see where your gaps are and stuff.
Yeah. Okay, so given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. Is uh yeah, so we want to start with like open parentheses to end closing parentheses and go from there. I want to generate all of them. So this might be a backtracking problem. This is what my intuition is telling me. I think
Mm-hmm. Why are you
yeah,
thinking that?
backtracking. Because I need to try like all different types of combinations. So I need to like one loop will be like, hey, I need to try a opening parentheses, open it again, and then close it, and like that. So I think that's what backtracking is good for.
Mm-hmm. Like trying all possible combinations type thing.
Yeah, trying all possible combinations. Obviously, like pruning, like we shouldn't start with the closing parentheses because that's not a valid one. So there are cases where it's not just trying everything.
Mm-hmm.
Uh, not sure how I can start this well. Uh, see, I should use something like a stack to track this, and when I reach the end of I guess the index, I want to make a copy of what I currently have on the stack and then push it onto my list of results. So use a result list uh, to track all the well-formed parentheses
Mm-hmm.
and push to that list when index I is the same as the length or n times 3, n times 2 in this case. So when I get to the end, then I can make a copy and push it on top. Now the problem is during this backtracking process, how can I make sure this is a well-formed parentheses and then go on from there. So
Like, are you familiar with how to implement backtracking algorithm?
um went through a couple of questions for the LeetCode ones, but in general, I can't really like do it well. I feel like I can't think carefully. Like I know I need to do like a for loop in there somewhere, but where do I start and where do I end
Mm-hmm.
is a problem. So I guess like like doing having like a backtrack and then of an index, and I know I need to do like if I equals to n times 2, then my result will be appended with stack.copy. Like this is like the end case, but for here, I know I need to do like a for loop, start from here or something, or then I'm not like I
Yeah.
get confused. Yeah.
Let's think about it a bit then. Like, what is the backtracking algorithm doing? It's building out that recursive tree, right? So
Hmm.
if we go into the drawing, like at some point you have the empty string. The
How
the
do I? Oh, click here to join. Okay.
the goal of the problem is to pretend we're given three, right? We need to generate all the valid parentheses
Hmm.
that have exactly three opening parentheses or three like pairs of parentheses. So like one is like this. This is valid, right?
Right.
Then it's like this. Like there's a few ones, right?
Right.
So that's the goal of the problem. Um, like when we do a backtracking, it's gonna build out some recursive tree, right? So you start with the empty. So
Hmm.
what are the options when you start with an empty?
We can push an open
You can push the
parentheses.
empty.
We can also push a close one, but we don't want to do that.
Yeah, that's
Right.
right. Okay, when from here, how many options do we have? Like pretend maybe we just keep track of how many openings and closings we have, right? So pretend we have one
Right.
opening. Like what can we do now?
We can do a close or another open.
We can like either open it again or close it, right?
Right.
Pretend n equals 3. Okay, what about on this point from this guy?
We can, since n equals 3, we can open again and then or close it.
Yeah.
Yeah.
Okay, what about this guy?
And then after we can't, we already have 3 open, so we have to start
Yeah,
closing.
you just pretty much just
Right.
start closing it.
Right.
And what about this guy right here? Is there options here?
We can still open once more, and then we have to start, or we can close.
So you could see how it starts building out the tree,
Right.
right? So I'll just like ponder about this a bit and try to figure out how can I write my recursive function to like say to like traverse the tree down, performing making these decisions each time. It's like at each you could think of each node as in like that what you mentioned right here in line 29 is like when you make a decision.
Decision.
Make a decision. Right. So here, depending on how many is open and how many closed, you're
Hmm.
gonna either like push opening or push a close and then recurse, right? That's what's happening in each node.
Right.
So yeah, what are you thinking? Yeah, think about it for a second. Hopefully that jogs your memory with how to do it.
Right. Make it this. So, right. We want to have like open and close. Know how many open and how many are closed. I think. So, let's see. If open is less than n, then we want to be able to still push either of them. Else, if open is equal to n in this case, then we can only push a close parentheses. And let's see. Stack, I want to append, and I also want to append a close parentheses. But the problem is when I append, after I append, do I call backtrack?
I think so. That's similar to like you push this onto a stack and then now you want to recurse in the like what happens here if open is less than n, yeah, open is less than n, then you push this to stack, right? And now you're here.
Right.
And then you want to recurse, you want to push it to stack and then you want to enter this backtracking function.
Yeah,
Ins,
want to
yeah.
append and then backtrack, but after that we want to uh, top it off, I think, so it doesn't mess with the stack. So backtrack, it will be open plus one, and I'm not sure about the I. One,
What's eye tracking?
I think where I am right now, but I guess we can just do that using the length of the stack, right?
Yeah.
So I guess we don't really need to do that. So, and then when I append this populator and
Well,
still,
let's think about this.
I don't know,
We want to append to the stack closing if open is less than n, but what if open is 0?
right, open has to be greater than closing. So I guess we should keep track of both values or just use um, close equals length of stack minus open.
Like the stack minus open.
That would work, I think.
Well, if it's all opens, 2 minus 2 would just be 0. It'll tell you that there's 0 close.
Yeah, zero close. So if if only when
Maybe,
close is greater than open should we
maybe keep track of open, or
start
maybe just
this.
pass in a close as a parameter. Every time you
This
open
is
one,
okay.
just pass in a close, like increment that.
Okay, yeah, that's probably clearer, better. So and then that's still close, and then when we do open, that's close plus one. And only when close is greater than open should we close it. And then uh, if open has we already used all the open, we have to uh, only close. And when open plus close equal to n times 2, we know our stack is correct. That's when we can append a copy
Hmm.
of it. And we run we start with backtrack of 0 opening and 0 closing. And
Yeah, let's try it on like, let's just try it with 1 or 2. Let's try it with 2. Or we need to tell it what the n is, right? Where's n?
what n is, yeah. So I guess when uh it's like, what should I call this function? Well form parentheses, and then we're only given an n, an integer, right? And then
Mm.
often, I guess I don't keep that's fine. We're just testing. So given an n, then can stop, and then we start doing this, and then we can return the result at the end. So should I see if I can try run this and
We walk me through line by line.
or well, yeah. Okay, so right, beginning we have n, which is the number of, I guess, open or closed parentheses. That's n.
Sure.
And we use the result to keep track of our what we return, empty list so far, and then the stack, which is, oh yeah, we need to make it. Already. I should join the stack and then append it because we're returning a list of strings. Yeah, okay.
Okay.
So we have a backtrack function where we count the open and current open and close count of the parentheses. So when we begin, we call 0 and 0. So we have 0 open and 0 close.
Sure.
And only when they add up to n times 2, 2n, can we stop and append that to our result list. And so here is when we want to make a decision. So when
Okay,
open
but
is less than that.
after this runs, what happens? We want to
Oh yeah, it's
continue.
gonna keep running. So we have to stop. We have to stop here.
Okay.
Right. And then when we open the number of open parentheses less than n, that means we can still push an open or we can start closing depending on if we have more close than open. So we can definitely put an open parentheses, we appended, and then we can backtrack with open plus one because we just appended an open parentheses, but we keep the number of close parentheses the same. And then the other case is if there are more close parentheses than open ones, that means we can still append a close parentheses.
If there's
And then
more
so we
open than close. If there's more closed than open.
if they're more close than open.
So if there's if there's one open and
Oh
two
no,
closed.
it's yeah, if they're more open than close. Yeah, if they're more open than close, then we can close, not the other way. Yeah. Close if they're more, yeah, then we can append and then close plus one when we keep to the backtrack again. And otherwise, if the number of open parentheses is already equal to n, then we can only append a close parentheses forward and then close plus one. I think that works.
Let's try running it. Like a few. Let's see. Moment of truth. Three. Sorry. Print. Oh, did it work? Let's see.
It's one. There should be five answers, and I think that works.
Yeah, it makes sense. Let's see.
Yeah, I think that one works.
Let me run this. What's this question? Okay, we're gonna run it and see. Like when you did the code walkthrough, it made sense. Just need to make sure. Nice, it worked. Good job.
Okay. Yeah, it's like for backtracking, like I get the gist of it or what I can do, but like when it comes to an actual implementation, I'm just like kind of blank out and be
Yeah.
like, what do I start with? What do I end with? And yeah,
I think this
it's
could
just
be simplified a bit more. So
okay.
like even if we just remove this, right? Let's just say if open is less than n, we can write it, right? I think this would even work. So how would this work? If open is less than n, we could push it,
Mhm.
and then like if, or but does this increase open? Oh no, if open is greater than close, I think this would still work. Let me try right.
This could still.
It's a small simplification, but it makes the code a bit cleaner. Let's see if this works. Yeah, I just removed that and it worked. So
Okay.
it's smaller. Yeah.
Yeah, like when it comes to like during interview implementation, like I'm not confident to write super clean code.
Mm.
Like I'm following my logic around and I do like multiple if else statements.
Yeah. But when doing questions, I would make sure to make it as clean as possible because if there's a bug, you need to be able to debug it, right?
Yes.
Because if you
Yeah.
have, if you yeah aren't able to debug it, it's gonna
Hmm.
cause issues.
Right.
All right, I think we have yeah. Let's get one more in. Let me look for a good question. How do you feel about that question so far?
Yeah, I think you're like it's hitting like on my weakness,
Nice.
especially these type of questions and during like the interview process
Mm-hmm.
and my approach. I think you can like I think you can already clearly tell like what I'm weaker with.
Mm-hmm. Okay, let me grab the next question. Let's get into the second portion. The second portion is
Yep.
more of a question that I made up myself.
Okay.
Um, let's see. I think I saw it somewhere. But what we're gonna be doing is we're gonna be given a grid. I'll show you what it looks like. We're gonna be given a grid.
Okay.
This. Let me just multiply this. Grid like this. Shoot. One, two. So we're gonna be given a grid. Some elements in the grid are gonna be -1.
Okay.
-1 means a wall. -1 equals wall. Right? 1 equals cell. 0 is just empty. Right?
Okay.
So I'm just gonna like create random walls here. Right? Like these are the walls. There's gonna be random walls,
Okay.
right? And then there's gonna be some cells that I'm gonna cover color green, like this. Um, Essentially, what we need to do is just figure out the number of islands inside of this grid.
Number of islands. So number of cells that are islands.
Like how many islands are here? Islands
Uh,
are like connected. What I mean by
right.
islands,
Connected
yeah,
cells.
connected
Connected cells,
cells,
right?
like
Okay. So
vertically
here
and
will be one,
horizontally.
two, three, four, five,
Yeah,
six, six, six. Okay.
yeah. Like,
Six.
what about this now? Are these connected?
Uh, these are not connected, right? Because they're not adjacent. It's diagonal, so that doesn't count. So it's
Yeah,
another new
yeah,
new like island.
yeah. So I'll write
Okay.
out the prompt. It's like find islands in a grid with walls. Islands are cells that are adjacent. Islands are cells that are adjacent vertically and horizontally. Not right. That's my description. Find islands
Right.
in a grid with walls, and then we're gonna say 1 equals cell, -1 equals wall, 0 equals empty. Return
Mhm.
the number of islands.
Okay. So, what's the distinction of walls and empty? What I don't think it matters in this specific case, right?
Mm-hmm.
Because we're just looking for islands, and this, if the cells are connected, it's an island. It doesn't matter if what's next to it are empties or walls, right?
Mm-hmm.
So is it just extra information, but we don't really need to use it?
Yeah, pretty much, I guess, if you look at it like that way.
Okay. So in that case, it's like finding islands, the number of islands. So I want to, I guess, loop through the entire grid, and whenever I encounter a cell, I probably want to use find all of its adjacent using something like DFS,
Mm-hmm.
and then mark the cell to empty or wall. And then when I return back, I add one to the number of islands.
You add one. Okay.
Yeah, I add one. If the grid is a cell, then I add one because then I will go through its neighbors and change everything to empty after.
Mm-hmm.
And then as I loop through, for example, here, does this show my cursor on your screen when
Yeah.
I'm
Yep. I see it.
moving? Oh, okay, okay. Yeah, so like I guess I loop through here and then I see this one, I add one to result, and then I mark this as empty, and then I loop. Oh wait, this one's up here. So yeah, if I come here, I see this, I mark all of these as empty using DFS, and then I add one because it's the first one is a cell. So I add one to the result, and I get here, mark all of this as empty, add one to the result, and then the next time I get here, this is already empty, so I just keep moving forward. And then when I encounter this one, I mark it as empty and then add it to the result and then go down. And then here, go down, and then here, and then here.
Okay. Yeah. I go
And
ahead and implement it. Yeah. I'm more just setting this up for a follow up, a quick follow
oh,
up.
yeah,
So
yeah.
go ahead and
Okay,
implement that.
so let's see. Given a grid, so I guess, oh, God, what happened? What the heck is happening to my, why is my D? I can't type D in here.
Try
What's
to
going
refresh.
on?
Refresh.
Let me,
Working for me.
uh, what is going on? Okay, maybe it's an extension problem. Hold
Did
up.
you try refreshing?
Yeah, I refreshed, but it's still being weird about it. Let me,
Like it's just not typing the word D. Or...
yeah, okay, I'm just gonna refresh it again. What is happening?
Are you in drawing mode?
Oh, yeah,
Yeah.
I think I
Just
am.
leave drawing mode.
Close it and then, no, that's still, what the heck is happening? Let me,
Try like
maybe
closing
my,
out the browser and coming back. Or are you able to type in the dot in? Were you able to type in the in your search bar, or is it just CoderPad?
okay, I disabled an extension of mine. I think it might be just messing with something.
I see.
Yeah, I had a Vim extension, a Vim commands extension. I think that's messing with the inputs. Okay. Yeah, so let's see. Given let's see, uh find islands, then given a grid. So I want to loop through every grid using DFS. So I'm gonna have to run a DFS with like row and column of some sort. And then for each row and column, let's see, for each row and column, if the grid is a cell, if it's a one, if it's a cell, then I want to run DFS at DFS there and add one to our island. Once we're done, we want to just return the result. So the problem is when I run DFS, how do I Check. Okay, so when I run here, I want to mark the grid as empty, as 0 now, and check the 4 directions for the directions of 1, 0, -1, 0, 0, 1, and 0, -1. Let's see. The new row is row plus row, and then column plus the new column, and if it's within the boundaries length of grid, and within the boundaries for the column, and the new grid and column is a cell, then I want to do DFS onto that new row and new column. And this doesn't have to return anything after, I believe. So I think this can work. Checks the 4 directions, and then if it's still within part of the grid, then and the grid value is 1 as a cell, then we want a DFS and we want to set it to 0. I think that works.
Wait, walk me through the code.
Yeah. So we use result to store the number of islands. And as I loop through the grid, if the grid has a 1, then equals 1, then I want to start setting it and all of its neighbors to 0, all of its neighbor 1s to 0s. So I add 1 to an island, and then I call DFS to modify the grid. So I set the grid at that location to be 0, and then check the 4 directions if it's still within the grid's boundaries, and that the cell value is a 1, then I want to run a DFS to it.
I see. Okay.
So I think that's good.
Yeah. Let's run it on this case real quick. One. One. Okay, run it on this test case right here.
Okay.
How many islands should this be? 1, 2.
This one should look like 1, 2, 3, 4, 5.
Yeah.
5 islands. Right. So
Okay.
yeah, 5.
Okay, we're gonna do a slight twist, right?
Okay.
What we need to do is we have the option to convert one wall to a cell.
Uh-huh.
Right? Wait, let me think about this. Basically, yeah, we want to convert one wall to a cell.
Mhm.
What's the biggest island what we can build? Like what's the biggest island we can create after we do this operation? Convert one wall to a cell.
Okay.
So right now the biggest island is 3 because we have 3, 3, 1, 1, 3. So biggest biggest island is 3, or largest island. But what we can convert one wall to a cell, and if we convert this one to a cell, we get a island of 7, right? So that's our goal. This is follow up.
Okay. Uh, convert to the biggest island. Okay. Convert one wall. Okay, so yeah, in this case, it will be converting this wall. It will become a seven island, an island of 7 size. Converting this one will create an island size of 5, but that's not the biggest one.
Mm-hmm.
So, okay. Um, let's see if it is possible to find the islands and set the size. Set the size, the area of the island. So this will be 333. This will be 33.
And
So
we don't have to implement this. We can just talk about some
okay,
possible
yeah.
approach. So,
Approach, yeah.
yeah.
So I'm thinking like if I set like this to be 333 because I know like I can find the area that's connected, and this is also 333. And then I loop through the grid to find negative ones, which are walls. And if I find a wall, I check its nearby 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 islands and see if I can add that up. But I feel like that's going to be a problem when the adjacent, I don't know which island it's coming from. It can be from the same island. And if I try to add it up, it's going to cause problems.
Yeah.
Yeah, so that I don't think that idea would work well.
Like, what's the brute force?
The brute force would be um, looping through everything and then set changing this as 1 and then run DFS at this location.
Mm-hmm.
Yeah, DFS location and find the yeah like -1 and then DFS is gonna find the nearby uh cells and return like a 7, and then I reset this, turn it back to -1, and then keep moving forward to see the next -1, and then convert this to a 1 and then find the area.
Okay, so just try to convert every wall into a cell and see how large the island it forms.
Yeah, yeah.
Well,
But I think
yeah,
that's gonna be pretty slow, right?
yeah.
It's gonna be, yeah.
What makes it slow?
Because we'll have to find the same island multiple times. If this one is a -1, this one's also a -1, this one's also a -1, we're gonna do DFS on the same island multiple times, right? So it doesn't feel that
Mm-hmm.
we should only do a DFS when we're connecting 2 separate islands.
Mm-hmm. But
In
like
that,
pretend we connect them, right? Like, how do we figure out
right.
the size of the island after we connect them?
Oh, wait. I think what if we use like a we use a like an ID number for each island. So when we loop through this, we know this is an island, and we set this to an ID 1 or ID 2. Start from 2. ID 2, and then this is this one is ID 3. This one's ID 4, and then this is ID 5. This is ID 6. So we use an ID and we use a hash map. The ID will link to the hash map. The hash map will contain the size of the island,
Mm-hmm.
and then each time we loop through and find a -1, find a wall, then we check its nearby 4 directions and find 2 different IDs uh, that give us, and then go to the hash map and find the area, and that gives us the highest area.
Mm-hmm.
plus one, which is the wall itself.
Mm-hmm.
I think that method would be better.
Yeah, makes a lot of sense. Cool. Thank you. How do you think you did? Like, how was that
Uh,
interview?
I think the second problem is okay. Like for this, I guess I would call this like a simple grid graph traversal. This one, I did more of these, like the gates, floods, that type of problem more. So I think I'm more okay with this. But for like backtracking, that's definitely still like one of my weaker areas.
Yeah.
Like backtracking, permutation, that kind of stuff, and then I get stuck on how I can write that backtrack function.
Mm-hmm. Yeah. No, I think you did really good on the second question. Even the follow up. If you look in my
Mhm.
list, that follow up is actually pretty much
Oh,
max.
is it on the? Is it that?
Making a large island question, which is actually technically code hard. So, job.
Okay. Is this a part of your 75
Yeah, it's
or?
part of my 75.
Oh, okay.
But I just want to build up to it.
75.
I didn't want to actually like the hard one right away.
Yeah,
Like
I
that's
didn't. I don't think I've never ever written that problem
yeah,
specifically before. So like, I think my intuition here is good. Like I try a few different approaches, and then I it clicked, and I found like the best way, and I can like express it. I think that's good. And
mm-hmm.
then obviously, like actually implementation, that's a different story. Like implement it cleanly after I explain it, that's a different story, and we'll have to see.
Yeah. But yeah, I would just suggest like working on those backtracking questions because those backtracking
Mhm.
it's actually boilerplate once you practice it. Just do a bunch
Okay.
of backtracking problems. If you spend a couple days on it, you'll get so good at backtracking. It's pretty boilerplate, as in you you try one option and then you backtrack by popping out the stack kind of thing. Like you saw the code, it
Mhm.
ended up at. I would study also the recursive tree and understand it.
Recursive
Make
tree.
sure you remember how we drew out the
Oh
recursion
yeah,
tree.
Join. Yeah, I think that's really helpful. I remember like whenever I watch like a backtracking problem for like neat code draws that tree, but then I always just like, what is that tree for? Does that help or?
Yeah, yeah,
So yeah, now I think it puts a clear mind, and like it makes the clear decision. Like, hey, in this case, I should try this and do that. It
yeah,
like creates like a decision tree for the backtracking, which is important. Yeah.
yeah, exactly. Yeah, I'll send you some of I made a couple videos on it too, like
Okay.
how to think about the recursion tree. I made a video on
Hmm.
that. Let's see if I have it. I'll send it to you. Wait, how to get to it?
Okay.
Yeah, but yeah, shit, I hit that. Whatever. Cool. Anyways, thanks for coming out. Gonna take on the
Yeah.
next guy.
Thank you so much,
Yeah.
man.
Hope you enjoyed.
Really
All
helps.
right. See
Thank
ya.
you.
Bye.
Bye bye.